This
today.
conference will now be recorded.
There we go, just recording the conference. So yeah, two different projects. One up north, close to kind of section territory here. One down kind of south of Birmingham. I suppose an obvious question is kind of how did the two schemes come to be in the same presentation? This kind of presentation originated in its original form following a request from Network Rail. They were having an internal conference in the autumn time, and we got a request to say, could you have a look at this theme of renewal projects on the railway and what kind of best practice, what do we mean by best practice, and what does that look like? So we kind of put our heads together, and Tony and I really came up with these two schemes, which we thought kind of bring out quite a lot of themes that we've dealt with and struggled with over the years on renewal projects, and certainly don't get everything right, but certainly, yeah, how we start to kind of get towards projects that work well. And so we're going to cover quite a few different themes today. Tony's going to cover the first half of the presentation. I'll cover the second half. Tony will do a bit of an introduction to the schemes, but just before we get on to that, just if you can have the first slide there. Yeah, this was a bit of a poll we did, and we don't necessarily have the functionality to get a digital feedback, but we can perhaps pick this up on the Q&A at the end. Be interested to hear people's thoughts on the call. So yeah, we kind of asked the Network Rail guys, what was your biggest challenge on the most recent big project or task, and we kind of put up 5 answers. I guess there could be a myriad of answers on this question, but we put 5 key themes to try and gauge what people's thoughts were on this. So on the most recent project, or a recent project, what was the biggest challenge? So the first one's around a lack of clarity on requirements or scope, or indeed a major challenge on the railway, this idea of scope creep. Second one we kind of put down was the funding aspect, insufficient funding available to complete the task. Option C, insufficient time to complete the task. So we're just trying to do things too quickly or not in the right timeframes. The fourth one, item D, was around the skill sets, and do we struggle sometimes to get the right skill sets together, which can be a challenge. And then finally, item 5, not having the right data or information. So I won't necessarily reveal at this point, but I'll perhaps reveal at the back end or in the Q&A what came top when we ran that poll with about 200 Network Rail engineers. I'd be interested to know what perhaps people's thoughts are on the call, but we'll pick that up in the Q&A. So that's maybe one just to bear in mind, and by all means have a think about that as we go through. I should say, in terms of sound, John or Phil, if the sound is a problem at any point, just shout up so that we know if there's any technical problems. But without further ado, I'll hand over to Tony, and Tony will give us an introduction to the presentation proper. Thanks, Tony.
Cheers, Stu. Thank you. Thanks everyone for having us. Just try and move the slide along. So in a presentation overview, as Stu mentioned, we've got 2 schemes to show to you today. The first one we'll look at is the phase 2 of Harbury Cutting Works, which is near Leamington Spa in Warwickshire. That was a major earthwork, deep cutting, 34 metres deep, which is where our 100-foot below comes from for the presentation. The second scheme we'll look at is a Leeds-Liverpool Canal underbridge up near Accrington, near yourselves in Lancashire. Replacement of that railway bridge, quite a tricky location, that one. And then, as Stu said, we'll come back together for a summary and any Q&A that there might be at the end. So first up, Harbury Cutting. So it's quite an old one. Originally constructed in 1847, finished in 1852. It forms part of the main line between Oxford and Birmingham. It was put together by Brunel, quite a famous engineer. It's their largest hand dug cutting in the world at the time. As I said, over 34 metres deep. There's a tunnel joining two cuttings in essence, and we'll see that in a minute from the next slide. But the tunnel in the middle was originally supposed to be a lot longer, but there was a lot of issues with the ground there, which subsequently is why we've ended up being there now. So the cut was left open with quite a short section of tunnel. The tunnel itself, as I've said, divides the cutting into two parts, east and west. Back in 2015, there was quite a prominent failure on the west cutting, leading to the line being shut for 6 weeks. Massive disruption. It's quite a busy piece of railway. It says they're carrying up to 80 passenger trains and 50 freight per day. So there we've got the site layout for you. To the left of the picture, to the west, is the site where we had the failure in 2015. So hopefully you can see my cursor there. So just to put that into a bit of context, there was 326,000 tonnes of earth removed from this site. And from the main road in the centre of the picture, heading left towards Bullring Farm Bridge, it's about 160 metres linear. Just to sort of position us where we are, you follow this line loosely north and you come to Leamington Spa, follow it down, it goes south. Next major sort of station, Banbury. This is the site we're going to talk about here to the right of the main road. And the added challenge with this one, as you can see, there's a bit of industrial estate sat right on the top of the crest of the cutting. Whereas the previous failure was mainly farmers' land, it was a bit easier to manage. So you can see the general arrangement of the works. If we just orientate ourselves to the left, in the turquoisey colour is the portal of the tunnel, with the railway lines running left to right across the screen. So within the turquoise is soil nail detail around the portal. Coming away from the tunnel itself, this is the slope regrade. Each colour represents a different grade of earthwork. The red hatched area you can see just to the left of centre of your picture is a previous failure along the crest of the cutting. There's a contiguous piled wall to retain all this industrial estate that we saw from the photograph. Down closer to the track, you can probably just make out the red lines. That's counterflow drainage heading down towards the track system. It's quite a big scheme overall, lots of parts. So in terms of the soil nailing, there are over 660 nails in total to be installed around the portal. Most of those were 6 metres in length, and then the closer to the crest, the shorter the nails were getting. In terms of construction, we worked so that we could use a long reach excavator where possible, safest means. So governed by reach, so towards the upper slope is where we were using the long reach. You can see my cursor there just above the tunnel portal. It's a bit of a catch fence and a handrail there that was installed that allowed us to work during the day, during normal operational hours for the railway. There's a temporary crest access system installed using sacrificial nails and wire ropes that allowed us to carry out A-frame working. And we used a nailing rig to install the nails that couldn't be accessed with the long reach. It says at the bottom there currently 300 nails installed, but they're all in now. Some pictures there just better illustrate what I was just going through. So the picture on the left, you see the access road here at the top, the catch fence down the bottom, and the rig working there mid-slope. Photo on the right, you can see again, you can see the tunnel portal with the green catch fence circling that. We've got some temporary access steps at the centre of the slope, and we've got the rig working to the left of it, and there's that long reach on the right there installing the nails in the upper slope. You can see there's extensive devegetation works carried out to facilitate construction. So in terms of the slope regrade itself, This is quite a nice drawing. Down to the bottom left, you can see a sleeper and a couple of rails there that just sort of scales out the whole slope for you, so you can see, you know, what sort of a job it was. As I said, there was various grades used along the slope. The dotted line was the existing ground profile, and the red line being the proposed, with the blue dotted line, the erosion map that was laid on top of that. So you can see there was a good bit of material when you take that out along the length of that slope we looked at. There's a lot of material to come out here as well. And again, at the crest, you can make out the pile in detail with a pile cap on the top there, and your access road in behind. In terms of removing that material from the slope, we wanted to work like hay baling, daisy chain, if you like. So we looked at the working radiuses of the machines. You can see circling them here. So you've got a small machine, medium machine, and a larger machine at the crest. So they're passing material one to the other up the slope. So in terms of the design, when we're looking at the construction factors, we needed to have berm details where these machines were going to sit. We had to make sure that they could reach each other, as I've said. So it was key that we kind of got that into the design as well for efficient working. Again, there's a photo just to illustrate what we were talking about. So you can see your smaller machines sitting along the lower slope, slightly bigger machine mid-berm, and then your long reach big boys at the top to take the material and load up to get it away. Again, plenty of devegetation going on along there, with the exception of a screen at the toe. Reason being, the tunnel sort of at the bottom center of this photo, and the last thing we really want is for the train to be coming out and seeing, you know, loads and loads of plants sat adjacent to the track. Don't want to be alerting the drivers. So yeah, that vegetation screen was left in situ while we were working. From the air, again, top left, we can see the tunnel. You can see that vegetation screen coming out of it there. You can see just the scale of the job again. You can see how so much earth came away on the other side. It's similar sort of figures. You can see this industrial estate at the top of the picture, you know, stayed open throughout. So where our access road was also their sort of main way in and out of the industrial estate. So to facilitate us getting in and doing this work, we had to install temporary access for the industrial estate to the rear. In terms of the piling detail at the crest, just say it's a contiguous pile wall, over 130 piles installed in bays. So quite a lot of piles. In terms of installing those, we used a Barrow BG30, which is over 100 ton in weight. It's quite limited because of the sheer size of the thing. It's nearly 27 meters tall. So it can only travel on a 1 in 10 grade, and it needs 1 in 30 to work, so even shallower. So we had a design come in for the piling platform, an initial design, multiple grades up and down. It was trying to make sure that we had that 1 in 30 to work, 1 in 10 to travel. So there's a lot setting out to be done, a lot of grading off to be done. So various bits and pieces on site. Wasn't really ideal. So again, construction factors feeding into the design decisions. The final piling platform design, you can see there was no grade greater than a 1 in 30. So at any position along that piling platform, the machine could travel or work. So it was easier to construct and much easier when it came to working. The piles themselves, because there were so many piles to be installed in a relatively tight area, we went with a guide beam. And the decision was made by the engineer at some stage early in the design, that it would be quite handy if, instead of once the piles were in, then having to break out the guide beam to install the pile cap, if one could be incorporated into the other. So the suggestion went to the designers, a bit of a detail of that. So either side of your pile, you've got the guide wall itself, and we were sort of suggesting a couple of linkages to bond into that pile cap at the top there. So this was sent off to the designer to look at, and it came back with a few minor comments on it there. So back to the drawing board. And we managed to agree upon this design in the end. So a few extra bits of tie in detail, but we managed to agree on that. So there's really good efficiency in using that guide wall as part of the pile cap itself. You can see under construction there, the formwork inside and the reinforcement on the outside. That's the finished guide beam there. The bower rig starting to install the piles through that, so you can really see the value of having the guide beam there, because it not only spaces the piles correctly, which means you don't need an engineer stood there constantly setting them out, but also ensures the verticality of the pile. The piles being so close together, the last thing you want is them to start encroaching on each other and have to be taking piles back out. It's costly in terms of time and financially. So there's the bower rig in operation there again. Took a couple of steps back so you can see the guide beam going through the centre of the photo, if you like. But that building to the rear of the rig is a two-storey building, so you can really get a feel for the scale of the rig as well. It's a lovely day that photo took as well. So this is us now approaching completion, January 2021. See the regrade works are complete. Just about make out the piled wall and the pile cap there at the crest. The boundary fencing in. We've used hydro seed on the slope, so we've got a bit of greenery coming through really quite quickly. This lower berm has been maintained as an access route, so the network rail maintenance staff or whoever else will be able to have safe access along this bit of track for inspections, where previously it was like red zone restricted. Another one there from the opposite end, looking from the tunnel out. You can see really clearly the counterfort drainage going from the lower berm down to track level. Starting to look a really nice, tidy job. Again, there at the top, you see that pile cap. So yeah, quite visually impressive, that one. Another one from above the tunnel portal. You can see all the soil nails in here as well. We're getting really, really close to finishing that one there. One of the real positives from this scheme was the community engagement. Obviously, the village at Harbury quite close by. Between the two schemes, there's a Murphy presence in the area for years. We're talking 2015, the original failure, probably a year on site to rectify that. Slight gap in the middle, and then back for the best part of a year to do the other side. So there was lots of interface with the local community. You can see there's a school come out to see the site. It's really important that children are able to see these things and understand not only what's going on, but also how dangerous construction sites can be. Hopefully, if that message gets across at an early age, then looking to kind of reduce incidents of trespass and vandalism further down the line. But rather than just rolling into a village and creating a load of noise and mess, it's really good to kind of join in and really engage with people and help them to understand the benefits after we're gone. one other thing to note from Harbury, while we were doing the embankment regrade and taking material away, there was some historical artefacts brought out as well. See there the picture on the bottom left, we've got an old bogie axle set, which would have come off a wagon similar to the one in the picture in the top right. And bottom right, on the bottom of the pickup there, there's an old length of rail dated between 1870 and 1875. The theory being that these would have been used to take material to site and carry out the maintenance works of the tunnel portal nearly 150 years ago almost. A representative of the National Railway Museum came to have a look and was on about taking them up to be displayed in the museum as well. It's quite a nice bit of history there. So that brings me to the end of Harbury, and I'm ready to pass back on to Stuart to talk to you about Leeds Liverpool Canal.
Yeah, thanks, Tony. So yeah, we're coming up north now for the 10 feet above, which is 10 feet above the canal level. This is the Leeds Liverpool Canal underbridge reconstruction. Underbridge renewals are obviously not necessarily ridiculously unusual. You know, we do them on a fairly routine basis, but this had a few more challenges than usual, and I'll explain why that was. So Tony's going to do the slides for me. If we can have the next slide, Till, thanks. So this is where the location is. So as I said, we're kind of up near Accrington. Accrington, the outskirts of Accrington town are just on the right hand side of that picture. You can see Accrington Golf Club in the middle of the picture, and then the M65 snakes around the top. Blackburn being off to the left. The railway line is the kind of the dark line running kind of diagonally from the top left towards the bottom right of the picture, and then the snaky line is the canal. Yeah, we're on the FHR 5 line. I imagine it's probably familiar to many of you. As John was saying before, from what I understand, I think the railway actually snakes back and forth across the canal in a few different places, but this one we're yeah, just to the west of Accrington there. It's 2-track railway, non-electrified, and we're between Church and Oswestwhistle and Rishton Station. And the FHR 5 route, as many of you will know, connects Preston, Blackburn, Rosegrove, and then on to Todmorden, and there's a route into Bradford as well. So next slide, please. So this is the existing structure. Yeah, just over 100 years old. So I guess pretty much par for a kind of 120-year design life, not far off really. Quite a standard bridge configuration for the time. So steel longitudinal girders. Slight difference between the two deck types. So one deck type having regular cross girders, the other one having rail bearers, as you can just see just towards the centre there of the archive drawing. Actually managed to get an archive drawing for this bridge, which was great. Sometimes we struggle, which goes back to that theme around data and information. But yeah, I guess in terms of size and span, nothing too complicated, but it's the location that really was the massive struggle on this one. In terms of drivers for the scheme, obviously condition there, you can see the paintwork's beginning to break down on the bridge, but then the bridge assessment, so the strength assessment, for those of you familiar with that, it couldn't meet the RA rating for the line speed, and this line does carry freight traffic, so you're into speed restrictions for freight, and then eventually potentially, if it gets any worse, you might be completely closing the line to freight and just using it for light tracks or loads only. So trying to intervene before we get to that stage. Yeah, masonry abutments, and it's over the top of a canal. The canal's an operational canal with towpath used by the public. Okay, I think next slide. So yeah, this gives you a bit of an overview of the location. the remit from Network Rail was to reconstruct the bridge. Normally with underbridge reconstructions, our first protocol would normally be kind of what we refer to as a drive out, drive in solution. So use a transporter module to lift the bridge up, drive it out, and then lift the new bridge into position and lower it down into place. Second option would usually be mobile crane if we can't use the transporter units. So bringing that kind of logic to this puzzle, we couldn't get it to work. So we've got a golf course on one corner of the bridge, which we're not able to transit across. One approach is completely landlocked, bounded by the canal, the railway, and the M65. So there's no practical means for us to get in that way. On one of the other corners, we've got a large historic landfill with contaminated land issues, not feasible for access. And then finally, on the one remaining corner, there's a surface laid, quite substantial diameter United Utilities surface water main, which couldn't be crossed in addition to listed coke kilns. So it quickly became a one where we had to scratch our heads a little bit to think, what could we do at this location? So yeah, had to get our thinking caps on. Next slide, please. Yeah, we began to think, what can we do coming in purely by rail? So the problem with coming in by rail is you're usually quite heavily restricted by your lifting capacities. RRVs in themselves can lift up to a certain amount, but certainly not really for substantial bridge works. So we started to turn our attention to the Kirov Cranes. What could the Kirov Crane do for us? Some people on the call might be fairly familiar with the Kirov Cranes used for S&C renewals and that sort of thing. We don't tend to use it quite as much in the civils work. We tend to use mobile cranes more, but in this case, we just had to do what we could given the constraints. So we kind of began to think along a segmental structure that could be lifted in parts using Kirov cranes, and eventually we came down to a steel concrete composite, which I'll just take you through now. So next slide, please. Yeah, just before I can jump on, sorry, to the bridge detail, we needed to have a satellite compound. So because we weren't going to have main compound at the actual bridge location itself, which is more common for us, we therefore had to set something up at a little bit of a distance away. So back down towards the Accrington direction now, we found a suitable piece of land. It was right next to the main A road, A679 Blackburn to Accrington, so we could bring significant size construction vehicles on the main road. It was also suitable in terms of constructing a temporary wrap. As Tony will know in more detail than myself, you're restricted in terms of track count and curvatures for wraps. So the road rail access point had to be suitable for use. As I said, we had to have good road access given the size of the wagons, the size of the components we've been bringing, and we also needed a decent plan area, just given the size of the laydown area that we'd need for all our construction vehicles, our welfare, deliveries and so on. So this is about 1 kilometre away from the bridge, so you don't want it too far because we're obviously going to have to transit all the components up to the bridge location. So this met our requirements, and so we now have got our satellite compound established in terms of location. Okay, next slide, please. So yeah, this is kind of linking on from what I was saying there about, usually we might start with the design and then figure out how we're going to build it. It was very much this way. In this case, it was figure out what we could build and then design around it. So basically, we worked with the guys at Rail to establish the capabilities of the Kirov crane for lifting. And then basically what we had to do was we had to design all of the components individually to basically meet the reach of the crane and the weight capability. So at a given reach, what could it lift, and therefore that was dictating what the component size could be of those units. So we've got steel longitudinal girders with steel cross girders, and then on top of that we're going to sit precast concrete units. And in the end, it was a significant number of lifts. I think I put it on one of the other slides what the exact number was, but I think you're looking in excess of 40 lifts, so it was quite significant. Yeah, and then the final one was we needed a stitch detail to stitch all the concrete units together. So we're doing this bridge in February 2020. So we have to bear in mind that any in situ works have to be able to sustain the climatic conditions of winter in Accrington. So yeah, enough to keep us busy. Okay, next slide. Yeah, onto the temporary works as well. So obviously we've kind of just about come to a solution which we think could work in terms of the actual permanent works, but then that's obviously never the end of the story. So we then had to start thinking about some of the temporary works that we need as well. One of the key things that the design was concerned about was potential overturning of the abutments or sliding of the abutments when the old bridge deck was removed. They couldn't rule that out. So we had to therefore safeguard against that, and a propping system was devised with the assistance of maybes who are well versed in these sort of large propping systems. For those who are kind of keen-eyed, you might ask the question, why is the propping system not towards the top of the abutment? Which is a very good question, and the answer to that is normally you would want to put that propping system as high up as you could to restrain the overturning forces. But in this case, we had to bear in mind the permanent works, and we were going to put some substantial precast concrete sill units, which meant breaking down the abutments. So that was the highest we could put it without compromising the ability to put those new sill units in. And we've got a photo further on where you'll see those sill units, and it'll make a bit more sense. Yeah, for the temporary works, you know, the pontoon, you can just about see the pontoon over the canal. So we needed a canal closure, we needed a footpath closure, in addition to the railway closure. And the pontoon just sits underneath that bracing frame there. But again, we can see that on another picture in a minute. Okay, next slide. Yeah, as if we didn't have enough fun already, another thing to throw into the mix again. This kind of comes back to the records question and data. So historical records showed that to the south, there actually was a former timber viaduct, but that was infilled by means of end tipping, which was quite a common form of constructing embankments. It's quite substantial. The photo's difficult to do it justice, but it's around 20 meters high, the embankment to the south of the bridge. There's some concern about the condition of that embankment, and for conventional traffic that risk is managed, but the question was raised when you're going to be lifting using the Kirov crane, you're going to put an abnormal loading condition on that embankment. It's not going to be conventional loading. So trains load it in one way, but now you're going to start loading it in a different way. Therefore, there needs to be confidence that we're not going to in some way induce some form of slip in the embankment while we're doing that. So we therefore had to do a piece of work around temporary works design for that embankment to make sure that we could justify the use of a crane in lifting operation, a Kirov crane in lifting operation while sat on top of the embankment. And that involved a category 3 check, so a fully independent check on those conditions, and it even required as well on-site geotechnical engineer presence while the Kirov crane was lifting. So yeah, a lot to think about, even off the end of the bridge structure itself, in addition to the bridge reconstruction. Okay, next slide, please. Yeah, this is Kirov Cranes. I'm guessing some people on the call might even be experts in it, more so than ourselves, but it kind of comes in kind of four sections, if you like. It can run in what they call consist mode. Its RA is relatively manageable. And can run on the majority of routes when in consist mode, but when you remove it and use it in lifting mode, then the loads are much more substantial. As you can probably see just from where the crane sits there, it actually spreads some of the load involved in the crane in transit across 3 of the 4 vehicles. So the loading actually is distributed. Yeah, I think next slide, please. Oh yeah, sorry, just one point on that previous slide, sorry. There was a limited capacity structure between the compound location and bridge 16, and that meant that the crane couldn't transit with loads on it. It couldn't carry loads while transiting, so we had to work out a solution for that. So I'll come on to that. Next slide, please. Yeah, so we're coming onto the main works now. This is the main delivery works. So we're into February 2020. The plan to transit the units was to have a mobile crane at the access point, and you can just about see in the centre of that picture the yellow jib of the mobile crane, which was going to lift the units onto the trailers with then RRV with trailers to shuttle the units down to site, and then they'd be lifted in position using the Kirov cranes. We actually needed 2 Kirov cranes, one on either side of the bridge due to the complex loading conditions. And that was going to be the plan until, as ever in railway jobs, something always comes to trip you up, and in our case it was Storm Dennis, with very severe winds. That actually meant that we couldn't use the mobile crane for some of the blockade period, which meant we couldn't load the units onto the RRVs to get them down to site. So a little bit of quick thinking and some calculations with the guys on the Kirov crane, and we figured out that what we could do is we could move the Kirov crane back down to the satellite compound, lift the units onto the trailers, then transit the crane back up to site and lift them into position. So managed to keep the job going, which is the name of the game. So yeah, just goes to show for all the good planning, there's always something that comes along at the last minute. Okay, next slide, please. So we're on to the job here. Here you can see the Kirov cranes in operation, 1 coalesce Kirov, 1 supplied by Volker Rail. This is some of the old bridge components coming out. I guess one of the key points to stress in this is when taking out the old components, you need to be very careful about your burn positions on the old bridge. There have been instances in the past where people have burnt components off in slightly the wrong place, and then individual component weights have transpired to be too high for crane lifting capability, and then you're into even more work to then get back to where you should be on your program. So very important to control your component size when you're taking the old bridge out. Yeah, so works are in progress. Yeah, this was a good slide in that you can see some of the elements that we were talking about before. So you can see the pontoon structure there in the canal closures in place, barriered off. Some temporary works required just to allow access from track level down to pontoon level. But as you can see, in terms of the actual location itself, we've got no compound and no access other than the actual railway corridor itself. So a very constrained site in bridges terms. Okay, next slide, please. So yeah, here we go. The old bridge is now out. These are the, on the left-hand side, you can see the large sill units there, which were the ones I was talking about, which were required at each end of the bridge deck. That necessitated the propping, as I said, going lower down on the abutment than otherwise might have been ideal. But yeah, it's again, it's a very tricky little piece of engineering to get it all to fit. But this is the new weathering steel decks, so 2 separate decks being lifted into position. So there's one deck in place. and the second deck going into position. Okay, next slide, please. So yeah, there you can see the two different Kirov cranes working from either side. As you can see from the night photo, it was a 24-hour operation during that blockade period, as is normal for railway operations. And the right-hand photo, you can see the two decks have now gone in, and you can just see the shear studs there, which will make the shear connection into the new precast units to be lifted into position on top of that. Okay, next slide, please. Yeah, some kind of photos towards completion just to finish off. So that's the tracks back in place again, ready for tamping. Okay, next slide, please. Yeah, and that just gives you an overview there. Again, just showing the surrounding vicinity. Yeah, it's looking quite a tidy job. Okay, next slide. And then finally, the name of the game, getting trains running again, and hopefully managed to hand back on time. So that brings us full circle, and I think we've just got a final slide just to finish off. Yeah, just going back to those 5 points, I guess, just to close us off there. We're going to leave a bit of time for Q&A in case anybody wants to chat about any aspects. But yeah, I guess those 5 big themes that we talked about at the front end, you know, having a clear scope, and I think that the scope on both of these schemes from Network Rail was very clear. We were clear what we were doing. We were clear what the limits of our scope was, where our work stopped. I think a big thing is time, and we've certainly found this as a major theme recently. Having that time to properly plan a job. As you can see, some of the complexity that goes into the planning is significant, and just having that period where we can properly understand what the challenge is and how we're going to successfully deliver the scheme is absolutely essential. And I'm sure all of us have been at the other end of the scale where we're just struggling to get done what we need to get done purely because we don't have the time to think and plan properly. The skill set question, I think the item D around skill sets and having the right skill set, there's a phenomenal number of skill sets which come into any project, and these two are no different. Temporary works, track design, civils design, the expertise that we needed from the guys operating the Kirov, numerous meetings with those guys to get that right. Railway planning, getting all our access planning right, how we were going to bring the Kirov Cranes in, from which direction. In the case of Tony's scheme and Harbury, the piling expertise, engaging those piling contractors early so that we know exactly what we're doing. There's no surprises. Yeah, and then last but no means least, and we've certainly found this at Murphy's over the last few years, the data question and having the right data available to us, whether that's archive drawings or ground information or track records, whatever it might be. It's just that whole piece around having the right information at the right time to make good decisions and avoid wasted time and money trying to go back and find information that's already available. So I think all 5 of those are key. I think in the end, Network Rail, the poll of the 200 guys from Network Rail, I think actually came out top. It was the first one around scope and scope clarity, which I was slightly surprised about actually. I thought funding might come up higher, but I think the Network Rail guys won out on the scope as being the biggest challenge. So yeah, that kind of brings us to the end. But John and Phil, we're very happy to have a go at answering any questions if we can. And thanks very much for listening.
Can't hear you, John.
think his microphone's on, isn't it?
It is.
Seems to be a bit of a problem, doesn't there? Yeah.